Okay? Number system. This is a classification of numbers. The real number system. So you might be asking yourself, well, what's cooler than that? What's unreal, dude? Okay? Don't worry, everything you do in this class is going to be real. Everything you do in grade 11 is real. Everything in grade 12, if you take Math 12, is real. Everything in public school is going to be a real number. So unreal, non-real, don't worry about it. But I'm going to test somebody. Hi, Alicia. Do you remember the answer to that? She asked me this in grade 8. This is not a real number, okay? And if you take math in university, then they'll teach you, oh, you know what? You actually can take the square root of a negative number, okay? But we're going to tell you you can't do that, all right? Okay, rational, irrational. That's what we did yesterday, not on the quiz, but quickly, give me an example of something as rational. Okay, we don't want to know what's irrational. We want to know what's rational. If it's not rational, then it's irrational. Okay, don't confuse yourself. We know something's rational if what happens? Okay, if something repeats like that, what's 1 divided by 3? Don't say 0.3. That's incorrect. It's 0.333. How many do I got to write here? It goes on forever and ever and ever. We abbreviate that by going 0.3 repeat. That repeats, therefore it's rational. Let's look at something else. What's 1/2 as a decimal? That doesn't repeat, but it terminates. It's a rational number. Okay? That's 2 of your 3 options. You don't even need to put those in your calculator because if you can write it as a fraction, it's rational. That's your only choices. If it's not repeating or terminating, or you can't write it as a fraction, then it's irrational. Okay? All right. Real numbers. Well, way back when, like cavemen type era, right? I don't know what do we call this? I'm not socials teacher. Mesopotamia? I don't know. They wanted to know who was richer. They wanted to know who had the most rocks. Okay? Well, how can you compare? How do you know? Well, someone has like this rock and that rock and that rock. I think that's more than this guy who has just this rock. They had to come up with some system, so they came up with a number system. I'm not going to delve too much in this, but there's 1. How many angles does it have? 1. Yeah, then they came with this. How many angles are there? 2. There's 2. Then they came with this. How many angles are in that number? 3. Yeah, 3, and so on, and so on, and so on. There's 4 angles in there, okay? And they determined, well, let's count. Right? This guy has 1 rock, this guy has 3 rocks, so he wins. He's richer. It was on a base 10 system, so when you get to 10, kind of starts over again, add another 1 to 10, so on and so on. How high can you count? Okay? These are called natural numbers. Natural. They make sense. But they couldn't see nothing. Nothing didn't make sense to them. Like, how can you have nothing rocks? I can't see it. It's not there. But it does make sense. Because if Bob has 1 rock and someone steals Bob's rock, it's gone. He's got no rocks. You can't count it, but it kind of made sense now to introduce this concept of nothing, 0. These are all the natural numbers. These are included in here. We're just going to add a 0 and call it whole numbers. Okay? This is something you need to memorize. then it made sense that Jack borrowed Jim's 3 rocks. So Jack owed 3 rocks. Well, what kind of number makes sense there? 3? Yeah, we need to introduce negatives because he doesn't own them, someone else does. He owes them, right? So this is called integers. It's all the natural numbers and all the whole numbers. These are all included in this set, but now we're going to introduce negatives, okay? Those are called integers. We added, subtracted integers in grade 8. Okay, we did. Hopefully everybody did. Did it lots. Okay? That's kind of your 3 classifications of, I'm not going to say the word whole numbers, because now that has meaning, ones that aren't decimals or fractions. All of these are rational, aren't they? They're all included in this set. Don't worry about this kind of weird language yet, but rational, okay, we call that Q in this book. I don't know where it came from, probably Latin. All right, N makes sense for natural, W makes sense for whole, I makes sense for integers, then we get to rationals Q. Okay? Remember, if it's rational, we can write it as a fraction. I don't care what A and B are. Okay? This says, don't worry about it yet, but I'll say it, where A and B are the set of integers, and B can't be 0 because you can't divide by 0. Okay? This is to make professors happy. That's our exclusions. You guys, let's not worry about that yet. Okay? We also have, there's rational and irrational. What's our best example of an irrational number? Thank you, pi. That's our best example of an irrational number. Okay? Why? Because it doesn't terminate, it doesn't repeat. And therefore I can't write it as a fraction. Okay, now this is weird. This is Q. This Q with a line on top means not Q. Okay? I didn't come up with this, sorry, but that's what this book's going to do. Okay? Non-repeating, non-terminating decimals. All of these are real numbers. Are we going to see unreal numbers? No.
Teachers, please excuse the interruption. Would all grade 9 students please go to room 120? Thank you. All grade 9 students to room 120. Thank you.
Okay. They're going to call this thing a Venn diagram. You're going to say, that's not a Venn diagram. They have to look like that. Well, okay, I'm not going to get particular here. There's a group that overlaps here. Well, I'm going to say this one overlaps with this one. This one's included in here. Guess what W stands for? Whole numbers. What's included in the set of whole numbers? Natural numbers. Okay? These are all included in the set of integers. Okay? And integers are the set of rational. But we also have not Q, not rational or irrational, and all of this is contained in real numbers. But like I said 4 times now, that's all the numbers we're going to see. Okay? Which is the most restrictive group? I'm not talking movies here that you guys aren't legal to watch. Natural numbers is the most restrictive, right? Okay? Because you're going to get confusing questions, just to warn you. It's going to be, use the word always, sometimes, or never. Is a natural number a whole number? Sometimes, never, or always? That's not one of your options, Emily. Thanks for breaking the rules. Always. Every one of these is included in here, right? But is a whole number always a natural number? Sometimes? Yes. They all are, except 0. Okay? See how confusing this can get? All right. That's all I'm going to say about that. For each of the following, write all the sets of numbers to which this belongs, from largest to smallest. So we got to go back and forth, okay? You guys aren't familiar with this yet. You don't have photographic memories that I'm aware of. 9, largest set. That's this one. Is it a real number? Of course. They all are, okay? Let's just do that. They're all going to be real numbers. We're not going to see any unreal numbers. Non-real. What's the next largest set this thing belongs to? Is it rational or is it irrational?
Rational. Rational.
I heard you. I just don't yell it out every time, okay, Tyrell? I know you know what you're doing, but when people give an answer immediately, other people, their brains stop. They stop thinking, if they were thinking at all. Okay, so that's real, and yes, it's rational. Now you keep going down. Is it an integer? Is 9 an integer? What's an integer again? You go up and you look. Oh yeah, sure, of course it is. Look. Okay, so it's rational. It's an integer. Is it a whole number? Yeah, for sure. It's 0, 1, 2, 3, 4, 5, or 6, or 7, or 8, or 9. And is it a natural number? Yeah, you can count 9 rocks, can't you? Okay, lots of sets here. 11 sevens. You know it's a real number. Is it rational or irrational? Can you write this as a fraction? It already is a fraction. That means it is definitely rational. Is it an integer? Is it -3, -2, -1, 0, 1, 2, 3, 4, or 5? Or no. So you're done. If it's not an integer, there's no way it can be a whole number. There's no way it can be a natural number, right? Because those are more restrictive groups. That's it. Okay? Real. It's real. Is that rational or irrational? Who knows yet? Did I highlight that in yesterday's lesson? I don't recall. What do I know about the square roots of numbers that aren't perfect squares? Well, yeah, it's going to be a decimal, but I mean, hey, so is that, right? If it's not a perfect square, it is always irrational. That was in yesterday's lesson. I think I highlighted it. Maybe I didn't point it out carefully enough. Always irrational, okay? If it is a perfect square, like 9, like 4, okay, like, I don't know, 121, it's rational. If it's not a perfect square, it's always irrational. Okay, how many more sets do I need to go through? It's irrational. Hey, none of these are included in this irrational box, are they? Yeah, because if it's irrational, there's no way it's an integer. It's no way it's a whole number. Come on. There's no way it's a natural number. Stop there, come on. There we go. Okay? -7's real. Is it rational or irrational? It's rational. Is that an integer? Yep. Is it a whole number? Nope. It's not 0, 1, 2, 3, 4, so on and so on and so on. That's it. You stop. Okay? Explain why. Everyone loves this word, explain, especially in math. Why does 9 belong to 5 sets? Here it is. But -9 only belongs to 3. Well, -9's like -7. Same thing, right? Why? Well, because it's natural and it's a whole number. That's it, okay? All you do is write out the groups and compare, contrast, okay? Well, here. This isn't English. Let's do like Twitter talk, right? 'Cause 9 is natural and whole. Don't tell Mr. Worley I said that. Okay, lastly, a wee bit on square roots. We're going to see this again tomorrow, and the next day, in the next 3 years of your lives. What's a square root again? It's not just, yeah, I know that. Okay, I can get the answer. You got to understand what it means. Because all of a sudden, oh, whoa. Hey, that's not a square root. Yeah, it is. What's the answer? If there's a number multiplied by itself to give us that, we call it a perfect square. That number happens to be 3. So I can take the square root of this, and it's a nice number 3. Is there something multiplied by itself to give us this? Yeah. So the square root of x squared is x. Okay, don't worry, we're not there yet. But here is a handy table of perfect squares. Jeez, this thing is temperamental today. If you're not that good on these yet, you're going to want to maybe put a little post-it on this page and refer back to it. It's pretty easy to make this table yourself though, right? Okay. What does this say? 1 times 1 is 1. Therefore, the square root of 1 is 1. 2 times 2 is 4. Therefore, the square of 4 is 2. Why am I going so slowly? Because when we get to cube roots, you guys are going to be, huh? But it's exactly the same thing. 8 times 8, 8 squared is 64. Therefore, the square root of 64 is unreadable. Yeah, doesn't like it. Nope. Okay, 8. That's terrible. The pen was doing fine up until this point. All right. Now, most of us stop here. Oh, Mr. Watson, that's unfair. You can't give us anything past 12. We only learned the 12 times table. Well, yeah, it's totally fair. Right? What's the square root of 169? Is there a number multiplied by itself to give us 169? Yes, it's 13. Okay? You can see that by prime factorizing it. Okay? 225. Is that a perfect square? Pretend you don't see it on this table. How do you find out? Well, as a little preview to your quiz, you prime factorize. That's 25. $2.25 is how many quarters? It's 9 quarters, right? And this is 5 times 5. This is 3 times 3. Are those all prime numbers? Is that prime factorized then? Are these all in pairs? That means this is a perfect square. Okay? And hey, there it is. All right. Estimate. I'll remind you on the assignment, but do yourself a favor. Don't use a calculator if it says estimate. We're all big kids. I'm not going to audit you, but on those first 12 questions on the government exam, where you're not allowed to use a calculator, you're really going to be doing yourself a disservice if you use it. Okay? Look on your table. What is this close to? It's bigger than that. It's bigger than that. It's bigger than that. Not quite as big as this. Which one's it closest to? It's closest to 49. I know the square root. Now it's working. A 49 is 7. So this thing's a little bit less than 49. So this is maybe like 6.8, 6.9. You know what? Let's just call it 7. Okay? That's a bad estimate, I guess, but it's still an estimate. Okay? And it actually says use whole numbers. Okay? So I'll do it that. Use a calculator to find the decimal approximation. Well, what is it exactly? I said it should be like high 6s. Let's have a look. Come on. 46, 6.78 or 6.8. Okay? Is that a reasonable estimate, do you think? Yep. All right. So that one's okay. Does this minus matter? No. Just use BEDMAS. You know what? Visually separate it from your brain. I want to do this first. What's this close to? Well, that's kind of like close to root 4. The square root of 4 is 2. So this is kind of close to minus, now combine it, 2. Okay? Try it on your calculator. Is it reasonable? Sure. Okay, now what do I do? This is looking like big kid stuff. What does this say? It says 2 times root 18, right? Just like that says 2 times x. We don't do the times because that looks really, really confusing, right? We drop that. 2x means 2 times x. This is 2 times root 18. So just like this minus, which is like a minus 1, separate it. It's 2 times, what's an estimate for this? That's the closest one. This is like 4, so that's like 2 times 4. Plus 5 times, what's the closest one to that? That's kind of like 6, right? 5 times 6. 8 plus 30 is 38. Now that's a little harder to put in our calculator, and this is why I'm telling you guys, get a good one, because if you do, it does BEDMAS for you. And I enter this stuff in exactly how I say it in English. 2 times root 18 plus 5 times root 37. That's a lot nicer than 37 square root. That's backwards, right? As I'm trying to tell you, some of you guys with your calculators. 38.9. Is that pretty close to 38? Hey, it kind of works. Not a bad estimate, right? Okay, is that reasonable? Sure. Not bad for not using a calculator. Okay. What do you do here? Work from the inside out. Let's forget about this one for now. Pretend you don't even see it. What's close to the square root of 95? What's the square root of 100? So that's like 10. Now bring it back. Okay, work from the inside out. I could be able to give you like 6 of these things, right? All right. Square root of 10, that's kind of close to 9, so this thing is kind of close to 3. Okay? And cube roots. The cube root of 1,000 is 10. We should know how to put that in our calculator. All right? Find your cube root button. Check it. 1, 0, 0, 0. Hey, what do you know? It works. That means there's a number multiplied by itself 3 times. That equals 1,000. Okay? That's what cube root means. How about a nice handy dandy table? All right, now same thing I did with squares. You're going, oh, why is he doing this? This is why. 1 times 1 times 1 is 1. Therefore, the cubed root of 1 is 1. There is some number multiplied by itself 3 times to give us this. All right? 2 times 2 times 2 is not 6. It's 8. Therefore, the cubed root of 8, is there a number multiplied by itself 3 times to give us 8? That number is 2. Okay? I'm not going to go down and do them all, but that's what it means. This is 3. You got to get familiar with, these are really, really, really common. Okay? These ones you will see too. But when you guys in this grade see the number 27, the first thing that pops into your head should not be 9 times 3. It should be cube root of 27 is 3. 64. Oh, cube root of 64 is 4. Okay? Not square root of 64 is 8. Got to get familiar with these things. It's always going to be these same numbers. Okay? And grade 11s, the ones who didn't get that familiar with it, well, now it's even that much harder for them. Okay? in pre-calculus. All right? 8 times 8 times 8 is 512. Guys, I don't even have that one memorized, okay? But what does this mean? If you see that, I mean, if you're allowed your calculator, you should be able to see if it's a perfect cube without prime factorizing it. Okay, if you have a calculator, you can cheat. If I said, is that a cube root, 512? Well, pull out your calculator and see, right? Okay, but if it says prime factorize it, like on your quiz in a few minutes, you got to prime factorize it if you want all the marks. Okay? Again, we're going to estimate. What's this closest to? Look on your table. It's closest to 8. So this is kind of close to 2. Okay? Cube roots, not square roots. 120. That's kind of close to 125. So this thing, the cube root of 120, there is no number multiplied by itself 3 times to give us 120. But there is one that gives us 125. So this thing is kind of close to 5. Should I check that one? Let's see what an estimate that is. 4.93. Is that a reasonable estimate? Sure. Okay. How do we do this? Uh-oh. And always look. Is this a cubed root? If there's no number here, what is it? It's a 2. If there's nothing there, that's square root. This is cubed root. It's going to take a few of you guys a little while and a few mistakes before you get recognizing it. Because nobody wants to look here. You think they're all square roots. All right? They're not. These are all radicals. Okay? I could get 6th root of something. Hey, estimate for this, 4 times, I don't have my square root table, oh no, what's closest to that for square root? 8 times 8, 64, 9 times 9, 81, which one is it closer to? Yeah, it's closer to that, so that's kind of like 4 times 8, minus 4 times cubed root of 70, that's the closest one. The cubed root of 64 is 4, so that's like 4 times 4. 4 times 8, 32. 4 times 4, 16. This equals, well not equals, it's kind of close to 16. That's my estimate. Okay? Should I see if that's reasonable? Or are you going to assume that it is? Yeah, well the teacher did it, so it probably is, right? But if you put that in your calculator to check, which I would do, but I want to save a few seconds. Don't worry, we're not going to do that, okay? 1 to 11 and 14 to 15. And again, if it says estimate, do yourself a favor and don't use a calculator, or you will be that much worse off when you get to the government exam.